Zeros of polynomials and then their multiplicity. So a lot of people struggle with finding zeros and understand what that means. So I thought this would be a good thing to go over. So I'm just going to review the same definitions we looked at before. That a polynomial is basically you have a series of terms with exponents on your variable, and it just goes from high to low. And of course, we have the highest exponent is part of the leading term. The number in front is the leading coefficient, and then the degree of the polynomial is based off of that highest exponent. And what we didn't talk about last time was smooth and continuous. So this is sort of part of understanding kind of the humps that we were talking about last time. So polynomials are considered smooth and continuous. So you can have graphs that are smooth but not continuous, or they could be continuous but not smooth, or you can have both. So smooth just means that it curves rather than having sharp points. So polynomial curves, but an absolute value, which forms the V, has a sharp point, so that's not considered smooth. Continuous basically means you can draw it without lifting your pencil off the paper. So a polynomial and an absolute value graph are both continuous, even if the absolute value is not smooth. But if you have a rational function, which you'll learn about later, that's the third picture here, that's a rational function where there's a gap, or if you have holes in the graph or jumps in the graph, those are considered not continuous. So just some more definitions there to kind of understand what makes something a polynomial versus not a polynomial if you're looking at a graph. Now again, to review, we have two basic shapes of polynomial based off of whether they're an even or an odd degree. The even, the left and right go in the same direction, and the odd, they're going in opposite directions. And when you're looking at just these basic shapes, this is new terminology called power functions. So it just means that you have a single term which has an exponent or a power. So that's why they get the name power functions. So if there's terms added on, it's not considered a power function. It's if you have one term, that's where we get a power function. But we've got the even and we've got the odd. And these shapes are important when we're talking about multiplicity. So you're going to want to remember the even and the odd, because we'll come back to that. So zeros. Zeros are all the values for x where y is equal to 0. So it's basically you're taking your equation, you set it equal to 0, and then you solve for x. So any x-intercept meets the definition of a 0 because x-intercepts are where y is equal to 0. But you may have zeros that are not x-intercepts because it's possible to have zeros that are complex numbers, and we can't graph complex numbers. So all x-intercepts are zeros, but you may have more zeros than just that. So if I can sort of make a diagram where zeros contain x-intercepts, but x-intercepts are not, maybe missing some zeros. Y-intercepts are not zeros because it's specifically values of x that are considered zeros. So this is something that I see a lot of times where people, they're asked to find the zeros and they find both x and y, but y-intercepts are not zeros. It's just the x that are zeros. So you're going to want to be very careful about that. So actually, let me go back to generally these shapes, these zeros. The degree, when we go back to the basic shape of the degree, and the degree of a polynomial, we talked about kind of the number of humps it has or how many times it turns. That's also kind of tells you how many zeros that you have. Basically, The degree of the polynomial means you will have at most that many distinct zeros, and distinct means different. So if you have an x squared, you have at most two zeros, or two different zeros, but you may have only one zero, or you may have none if they're all complex. An x cubed may have at most three different zeros, but it could have less than that depending on what it looks like. But that's the maximum number of zeros that you can have, the maximum number of different zeros. So your degree gives you an idea of how many numbers you're looking for, how many zeros that you have. So there are basically two ways to find zeros, algebraically or graphically. And unfortunately, graphically doesn't find all of the zeros because it only finds the x-intercepts. It does not find any complex zeros. And if you're looking at it graphically, sometimes the x-intercepts are not whole numbers, and that makes it very difficult. So graphically is not going to be your only source of finding zeros, but it can definitely help you out. Algebraically is the only way that you can find all of them. And so that's what we do, is we don't rely on the graph. We can use the graph to guide us, but it's not the final answer. So to find zeros, you set your function equal to 0, and then you're solving it for x, which basically means you're going to try to factor whenever possible. And if you can't factor, that's when we use things like synthetic division, where you have to use these. Well, we use synthetic division in concert with other theorems to kind of guess where zeros might be, to kind of force us to factor it without using our other factoring rules. Looking at the graph can help you know what numbers to use for synthetic division, so you can use those in concert to factor manually. Or there are some things where you just can't factor at all, and then we have to use a computer to brute force it. But that's beyond what we're going to do in this class. We're basically going to be given problems that you can factor either immediately or by using synthetic division. And then once you factor it out, you set each factor equal to 0, and then you solve, and those are going to give you your x values, which are your zeros. So multiplicity of zeros. This is basically how many times that zero shows up in factored form. So if you have something that has degree x to the 4th, there's 4 zeros. But so it's possible you may have the same number in there 4 times. So you may have 1 0, but its multiplicity is 4 because it shows up 4 times when you factor it, but it's one distinct zero. So this kind of, this is related to the fact that the degree is the maximum number of zeros, distinct zeros you may have. And graphically, you can kind of figure out the multiplicity by looking at the graph. So if it crosses the x-intercept, then that means it has an odd multiplicity. So what I mean is if I have, this is my x-axis here, and I have like an x-intercept, if my graph crosses it, that means it has an odd multiplicity. So it's either a multiplicity 1, which means it shows up once in the factored form, or maybe it shows up 3 times in the factored form, or 5 times in the factored form, but it's considered an odd multiplicity. And it's actually, you can see, I said to remember those basic shapes of polynomials. It's sort of like the odd degree polynomial. So we have an odd degree polynomial where the left side goes down, the right side goes up. And when you look at it zero-wise, an odd degree or odd multiplicity will have the same shape. So that means if you have a 0 with an even multiplicity, that means it's going to kind of bounce back up so it looks like an even degree. So our shapes even show up when you're looking at just the zeros. So if the graph bounces or touches an x-intercept, so let's say I have a x-intercept right here, and it doesn't matter whether it bounces or touches it going up or down, but let's say it kind of bounces back up or back down, if when you're at that x-intercept, it touches the x-axis and then it comes back. Now, mine doesn't touch because I'm just really bad at drawing, but that's supposed to touch. But if it bounces off, that has an even multiplicity, and you can see it looks like our even polynomial. So when you zoom in at the zeros, they look like the multiplicity looks like the shape of even an even or an odd polynomial, which is kind of cool. So graphically, you can kind of determine how many, or the multiplicity of zeros. So that can help you when you're trying to determine the number of zeros. But of course, if there's any complex zeros, graphing is not going to help you. But at least it will give you some information that can help you narrow things down. And it's really helpful if you're trying to match like a graph to an equation or something like that. Using these little pieces of information can be really helpful. So I'm just going to go through, we're going to be finding zeros, we're going to be finding the multiplicities, we're going to graph them so you can visualize them. All of the problems that I'm doing here are designed so that you can factor them. Or in this case, they're already factored. So these are all things that we can factor, so we won't be doing any synthetic division or anything like that. So we're going to find the zeros and then state the multiplicities. So when you have something that's already factored like we have here, each factor gets set equal to 0. So I'm going to have negative 2x to the 4th equal to 0. X plus 1 cubed equal to 0. And x minus 2 squared equal to 0. And then we're going to solve each of these equations for x. So the first one on the left, if I want to solve for x, I need to solve for x to the 4th. So we need to divide both sides by negative 2. And 0 divided by anything is 0. So we're left with x to the 4th equals 0. Now to solve something like this, it's like we're taking square roots, but in this case, we'd be taking the 4th root in order to get rid of the x to the 4th. I usually write it as a 1/4 exponent to cancel those out. To cancel out an exponent of 4, you take it to the 1/4 power. So those cancel out, and we're left with x. And 0 to any exponent that's not 0, any non-zero exponent is equal to 0. So we get a 0 of 0. So 0 is one of our zeros. I know the language here is kind of weird. And its multiplicity is 4 because it was an x to the 4th that this came from. So now let's look at the one in the middle. We have x plus 1 cubed equals 0. Now to undo a cubed, I can take the cubed root, or basically raise it to the 1/3 power. And that will cancel that out, and we're left with just x plus 1. And then 0 to any non-zero is 0, so that's still 0 on the right. So we just subtract 1 from both sides. And we get x equals -1. So our next 0 is -1. And here, the exponent on that factor was 3, so this has multiplicity 3. Now the equation on the right, we have x minus 2 squared equals 0. So to solve this, we could take the square root of both sides. And we get x minus 2 square root of 0 is still 0. So we add 2 to both sides to solve for x. And we get x equals 2. So 2 is our third 0 here. And the exponent on this factor was 2, so this has multiplicity 2. So what this means, as far as if I was to graph these on a graph, I would expect that on 2, we're going to kind of bounce off of 2 if we were to graph it. So I think this is going to end up going down this way. So it's going to kind of bounce off of 2 because it has an even multiplicity. And I drew it downwards because that leading coefficient's negative. And so I know, and this is going to be my far right 0, so it's probably going to go down that direction. I'm not going to worry too much about how I'm figuring out the graphs here. I just want to kind of demonstrate what these would look like. Here we have a 0 of -1, and it has a multiplicity of 3, so that means that it's going to go through the 0. So let's see, I think it's probably going to go something like this, I'm guessing, where it's going to be kind of going through that point. And then here we have a 0 at 0, and it has multiplicity 4, which means that it is even, so it's going to bounce. So it's probably, and again, I'm guessing based off of my other knowledge about this problem, that it's going to be an upside down, but it's going to kind of bounce off of 0 at that point. So we can test this by actually graphing it so you can kind of see what it's going to look like in Desmos. So I'm going to just put in the whole equation that we have, -2x to the 4th. And then we have x plus 1 cubed, and then x minus 2 squared. Okay, so I was actually, let's zoom in, and I'm going to modify my x-axis here. Okay, so we can zoom in. We have 1, 0 here at -1, and multiplicity 3 means it kind of goes through, it crosses through, and you can see that it kind of has that odd shape like an x cubed, and that matches what I kind of drew here for x equals -1. Then our next 0 is here at 0, and so it kind of bounces off. It kind of looks really flat here, but it is kind of, it's not crossing the x-axis, it's just touching it and then coming back down. And then our next 0 was at 2, and that was another one that had an even multiplicity, and it bounces off. Now the one thing to note is that 2 has a multiplicity of 2, while 0 has a multiplicity of 4. The higher the multiplicity, the flatter it is when it bounces. So that's why the one at 0 is flatter than the one at 2, because the multiplicity is higher. And the higher degree you have a polynomial, the flatter it tends to be in those middle points. And so that's corresponds here. So this is 4 because it's flatter than this one, which has multiplicity 2. And then this has multiplicity 3, so it's relatively flat. If it was a multiplicity of 4, it would look like a line going through there. So they're kind of modeling the different polynomials when you zoom in at the zeros based off of their multiplicities. So here's another one that is factored for us. I certainly would not want to factor this one because it has square roots in here. So each of these, you set each factor equal to 0, and then you solve, and then that will get you your 0. So we have 4x equals 0, 5x minus 1 equals 0, 3x plus 8 equals 0, x minus the square root of 5 equals 0, and x plus the square root of 5 equals 0. So when we find our zeros, the first equation, if I divide both sides by 4, 0 divided by 4 is 0, so we get 0 as one of our zeros. Here, for 5x minus 1, I need to first add 1 to both sides, and then I need to divide both sides by 5. So we get x equals 1/5 as another 0. Our third 0, we solve 3x plus 8 equals 0. So I subtract 8 from both sides. We get 3x equals -8. Divide both sides by 3. We get -8/3. And then the next two, I add square root of 5, and then I subtract square root of 5 from both sides. So I get x equals the square root of 5, and x equals negative square root of 5 for each of these zeros. So all of my zeros here, I have 0, 1/5, -8/3, square root of 5, and negative square root of 5. So those are all the x-intercepts. And then their multiplicities, because none of them have any exponents on them, all of them have multiplicity 5. I mean, multiplicity 1, not multiplicity 5. The total degree of the polynomial is 5 because there's 5 of them. So Christian, go ahead. You have a question.
Good evening. How you doing, man?
I'm good. How are you?
Pretty good, pretty good. How's your foot?
It is better. So not broken. I actually went to a chiropractor today because it's still hurting, and he was like, yeah, your bone's kind of out of joint here. He did some magic, and now it doesn't hurt. So
Okay, right there.
earlier.
It's good to hear. It's good to hear.
Yes.
So I had a question about this here. I found myself in one of the assignments that I was kind of getting stuck. And this is more of like a simplified way of doing it instead of trying to follow the examples in the book, because I found myself getting stuck trying to keep up with the examples and going back, looking inside the embedded videos within the textbook.
Yeah, if they are factored for you already like this is like the easiest way to do it.
Roger.
The next example, when they're not factored, that's where it's not, and then you do have to do a lot more work.
Okay, okay then. Yeah. Is this just for this week's stuff here, or is this for the previous week? Okay, this week.
This is week 6 stuff. Where you cover the synthetic division, and you have all those different rules, but one of the most common things that you're going to have to do is find zeros, and this will show up again on the final exam. So
wow.
Definitely going to want to remember this.
Roger. All right. Thank you.
You're welcome. So with that, let's move on to one where it's not factored for us, because this is good practice. So again, all of these I've picked out specifically because they should factor. So we shouldn't have to do any synthetic division, but we still have to go through the work to factor all these. So we want to find the zeros, we need to set our entire equation equal to 0. Now, we want to look for greatest common factor that we can factor out here, so that way we can then continually factor the rest of it. So because my leading term, the highest term there, has a negative, we're going to factor out a negative, because whenever that first term is negative, we always factor out a negative. And I can divide all of the numbers by 2, but 6 doesn't go into any of them. So the greatest common factor will be 2 out of all the numbers. And then I can factor out an x because there's an x in all of those. So I'm basically dividing a negative 2x every term. So that leaves me with a 3x squared. I got to remember to change the sign. And get my eraser. So that's a minus 26 divided by 2 is 13x. Then plus 14 equal to 0. So now we have a quadratic equation that we need to factor. So we can factor this with guessing and checking. I'm trying to think if that one factors, if we need to use the quadratic formula. This one factors. Okay, so we don't need to do the quadratic formula on this one, but sometimes you may have to do the quadratic formula. But this one actually factors. It took me a while to think it through. So we have a 3x and an x here to multiply to the 3x squared. And then to multiply to 14 in the back, the numbers are either 1 and 14 or 7 times 2. So I was doing some thinking, I was running through the possibilities in my head, and it's 7 times 2. And these need to multiply to a positive but add to a negative, which means both of the numbers have to be negative, because 2 negatives multiply to a positive, but they still will add to a negative number. So if you want to double check, our inside is negative 7x. The outside is negative 6x. And negative 7x plus negative 6x gives us negative 13x. So that all factors out. So we've got it factored, and we want to go as far as we can. So we went all the way down to linear factors, and so we're done factoring. Now we need to solve. So we need to set each of these equal to 0. So I have negative 2x equals 0. 3x minus 7 equals 0, and x minus 2 equal to 0. And then we're going to solve each of those for x. And we got x equals 0 for the first one, because 0 divided by negative 2 is 0. The second one, we add 7 to both sides, and then divide by 3, and we get x equals 7 thirds. And then the last one, I add 2 to both sides, I get x equals 2. So our zeros are 0, 7 thirds, and 2. And because all those factors, we didn't have to take any square roots or anything like that. All of them had a degree of 1. These have multiplicity 1. All 3 of them do. And so there's 3 zeros. We had something x cubed. So that works out because the degree of the polynomial, that highest degree, tells you how many zeros you should have. So since it was x cubed, we should have 3 zeros. We have 3 different zeros. And you basically can multiply them by that multiplicity. So each 0 times the multiplicity, you add that up, and that should be your total degree. So all of these were multiplicity 1, so we'd just be multiplying by 1, but it adds up to 3, so we're good. We found all of the zeros. Now here's another one. This is a little more complicated. And this is one where there is no greatest common factor to factor out here. So we have x cubed plus 5x squared minus x minus 1. So in order to try to factor this, we could try to do factoring by grouping. because there are two terms, or we can use our synthetic division to try to factor. I think maybe that would be a good way for me to show you how to do that, how to do synthetic division on something like this. And I like to do it in concert with a graph. So I'm going to just graph this in Desmos because that will help you know what you need to, what numbers to try. It's also going to tell you the zeros, but that's okay because we still need to show the work. So I'm just typing in my graph, and then I'm going to have to like zoom out here. Okay. And so our zeros, we're looking at these x-intercept kind of things. So to do the synthetic division way of factoring this out, so I need to take all of the coefficients. I have 1, 5, -1, and -5. And I set my synthetic division up slightly different than the book does. I make it more of a table form than anything else. And that first number drops down. So to kind of guess where these zeros are, the kind of the cheater way, since we have technology, is to look at the graph and then see, okay, where are the x-intercepts on the graph? So we can pick the where we say, okay, there's an x-intercept at -5, so that's a 0. So to basically do that with synthetic division, so you'd put your 0 right there, -5. And then with synthetic division, we multiply these two numbers together. So -5 times 1 is -5. And then you write it on top of the next number and add going down. So -5 plus 5 is 0. Then we multiply -5 by 0. So that's 0. We write it on the next number. 0 minus 1 is -1. Then we take -5 times -1. So that's 5. 5 minus 5 is 0. And you know it's a 0 when you end up with 0 in that last spot. So that kind of verifies that it is a 0. So what we do with this synthetic division is that we've basically factored out an x plus 5. So it's the opposite sign of that 0. So -5 gave us a 0, so the factor is going to have the opposite sign. So that's going to be x plus 5. And then, and let me write this in with a different color. Originally, we had an x cubed up there, so we're basically dividing out a factor. So this is an x squared. We have 0x, and then we have a -1. So we would be left with x squared minus 1 left over after we divided that out. So we have basically just factored out an x plus 5. And now once you get to a point where you have something quadratic, then you factor that quadratic. So x squared minus 1, we can factor that out as x plus 1, x minus 1. And so if you have something that's a higher degree than an x squared, you can kind of use the graph so that you know what number to divide out. And then once you divide that out, then you can keep doing that until you get something x squared, and then you can factor the quadratic. So now we have factored this function, and so now we can find the zeros by setting each factor equal to 0. So we have x plus 5 equal to 0, x plus 1 equal to 0, and x minus 1 equal to 0. And when you solve those, we get x equals -5, -1, and 1 as our zeros. So -5, -1, and 1. And because each of these showed up only once in our factor, these all have multiplicity 1, just like the other examples. Actually, I should make sure I copy down the directions. I need to have good habits and do exactly what I tell you guys to do. Solve 4t squared plus 8t less than 5t plus 2. And then we're going to write in interval notation. Okay, so in order to solve a polynomial inequality, whenever we're solving any polynomial, we have to get one side to be 0. So I need to actually distribute 5 through the parentheses here. So that's going to be my first step. So 4t squared plus 8t less than 5t plus 10 when I multiply that out. Then I need to get everything on the left side. So we usually want these on the left side. So I'm going to subtract 5t from both sides. And then we'll also subtract the 10 from both sides. But I don't really have anything to line that up with. So I'm going to just kind of write it that way. But we get 4t squared. 8 minus 5 is 3t. Then we have our minus 10. And then, oops, not t. It's supposed to, oops. That's got to be 0. 10 minus 10 is 0. Okay, so now we want to factor this quadratic. And these are all designed to be factored. So you said you tried the grouping method?
Yes, I tried to do the factoring piece, and then I looked up online. You know how you get on YouTube, looking at videos, and I kept running into this roadblock where when I was doing the factoring, my last number I get a different sign, or with my middle number, where you got the variable 3t, it'll be another number. So I kept trying and trying. So I got past that, got over that hurdle. When it came to my final answer, getting the interval notation, my answer was
That's where you messed up.
Yes.
Probably from the graphing portion of it. So I'll do this by the grouping method or the AC method to factor this, where you multiply the first and the last numbers together. So that will give us negative 40. And then we're looking for two numbers that multiply to negative 40 and then add to 3. So 1 times 40, 2 times 20, 4 times 10, and 5 times 8. And to get to a negative, we need to have one of these signs be negative. And because we're adding to a positive 3, I need to make it a negative 5 here. So negative 5 plus 8, that will get me my positive 3. So I have 4t squared minus 5t plus 8t minus 10. And then I have my less than 0. And this is probably where your first mistake was. You probably messed up the signs at this part when you were probably had like a backward sign, just kind of messed them up. You know, use the wrong order, put the negative in with the wrong number. So my first grouping here, I can factor out a t, which leaves me 4t minus 5. And then I have my plus sign. And then the second grouping here, I can divide a 2 out of the 8 and the 10. So that leaves me with 4t minus 5 again. And so then that leaves me for my factors 4t minus 5 and t plus 2. And then we have less than 0. And you can use FOIL to double check that all of your signs are correct. It's usually if the sign is wrong but the number's right, you just have to flip-flop the signs. So once you've done this, then you need to take each factor to figure out where they're equal to 0, because we use those zeros as kind of our break points of where see, when we're solving a problem like this, we're basically saying, okay, we want our y values to be less than 0 because we're looking at where is this function less than 0. So we're looking at where are y values negative. And so your graph is going to be in the negative portion of the y, the positive portion of the y, and the polynomial shapes can go all back and forth between these. And so the zeros are where it switches signs from like a positive part to the negative part of the graph. And so that's why we care about the zeros, because those are our division points where it switches from negative to positive for the y value. So you just set each of these equal to 0 to solve. The first one here is going to give us 5/4, and then the second one will give us -2. So once you do that, you can't just jump to the inequality, the interval notation part, because you have to make a graph to figure out where is it positive, where is it negative, all of these signs. So we draw a number line here, and we put our zeros on the number line. And I don't really care what happens except for at those 0 points. Because we have a less than, that means the zeros are not included in our intervals. So we use a dashed line to indicate that these zeros are not included. Then what we do, or what I do, is I take each factor and I just write them kind of on the top. And then the multiplication, I kind of write down underneath. So basically, I'm making a sign chart where I'm going to be saying, is it positive in this section or is it negative in this section? And then you multiply those signs to determine if the overall polynomial is positive or negative. So what I do is I basically plug in a number in each part of the number line. So let's say I plug in -3 for x for that first section to the left of -2, or not for x, for t in this case. So I just plug in a number smaller than -2 in for t, and then I do the math and I say, am I going to get a negative or a positive? So 4 times -3 is -12 minus 5, that stays negative. So I'm going to just write a negative symbol there. And then when I plug -3 into t plus 2, -3 plus 2 is -1. That's also negative. And then the multiplication of these signs, a negative times a negative is a positive, so I put positive underneath where I'm indicating my multiplication. What this is telling me is that if I were to graph the left side, it's going to be, the y values are going to be positive to the left of -2. Now I'm going to look in the middle, and I want to pick a number that's between -2 and 5/4, and 0 is a really there. So I'm going to plug in, oops, I temporarily lost. Are you able to see me still? Because apparently I got disconnected slightly.
Roger, I can see you.
Okay, good, because all of a sudden my screen like changed. I'm like, whoa. So 0 is an easy number to plug in. So if I plug 0 in for t, for 4t minus 5, that's going to be 0 minus 5, I got a negative. And then for t plus 2, that would be 0 plus 2. I'm going to get a positive number because that will be 2. And then negative times a positive is a negative. So that means between -2 and 5/4, our graph is going to be in the negative part of the graph, of the y-axis. We're going to have negative y values. So then I want to move to the right side. I want a number bigger than 5/4. So that's 1.25. I like to plug in whole numbers. So I'm going to plug in 2. So that'd be 4 times 2 is 8 minus 5. That's 3. So that's a positive number. 2 plus 2 is 4. That's a positive number. And then a positive times a positive is a positive. So that means all the y values on the right side are going to be positive. So if I was to kind of take this and graph it, my graph would be positive, and then it kind of goes negative, and then it comes back positive again. So it's going to look something like this based off of these signs here, the signs from the multiplication. That tells you what the graph is going to look like. So basically what we're looking at is right here, and we're looking at where are we less than 0, where are we negative. And so that is the portion right here where our graph is below the y-axis. So that is the portion where we are negative. And so we're going to write our answer in interval notation based off of the zeros, the endpoints here. So our endpoints are 2 and 5/4. And then because it's a less than, not a less than, or equal to, the less than means that you use parentheses. So our answer, I tried to squish this all on this screen, is basically going to be -2, 5/4. And let's see if hopefully, so when I enter that in here, I have 2 sets of parentheses here. So I'm going to just verify 5/4, make sure I didn't make any mistakes. Okay. And you can check your answer graphically, but when you check it, you're not going to graph this part, the original problem. When you check, you want to graph the part from when you put everything on one side. So like the 4t plus 3t minus 10. So I can bring this up, and I can bring up Desmos. And I can use t here, and Desmos will still graph it. Let's see, it should. Oops. -10. Okay, it doesn't actually want to graph it, but I think if I say f of t, there it goes. So we put everything on one side, and if we ignore the less than 0, we have 4t. Oops, that wasn't +8, that was plus 3t minus 10. And so those zeros that we factor, that we solve for, we can see on the graph are -2 and 5/4, or 1.25. And that sign chart that we used based off of the factored form was basically telling us, oh, our y values are positive to the left of this 0. Then it was negative. Then our y values went positive again. So that's essentially what our sign chart is doing without ever looking at the graph. And then because we're looking for where this is less than 0, we're saying, where are the y values less than 0 or negative? And then that's this bottom portion right here. And you just have to, you're looking at, okay, between what x values is that true? Does that help?
Ooh, yeah. So, I wish I had the sorcery behind the math right there, what you got, the mathematician, the sorcery, and all that good magic.
It takes practice, because I was not always this good at it, I mean, when I was in higher level math when I was in high school, but I was on the dumb side of the room, as my classmates and I said. So I was certainly not one of the smarter math people in my classes.
Roger.
So it takes practice, and what helps for me is being able to connect it back to a graph, because then I can kind of visually see what the math is telling me, and it just makes things it reinforces it to me to see, okay, I just made this chart, now what is this chart telling me? And then I can look at the graph and say, oh, these are actually giving me the same piece of information, they're just in a different form.
Looking at the like when you went to the actual part where we do the assignments, I click sometimes I click on the explanation or the examples, and yeah, would you click there? So
yeah,
it had like inside the book, I was like, okay, do I need to follow the book? So looking, you see how they have it, and then if you scroll down there, it has
Yeah,
like
what they're doing here.
right, yeah, that threw me out. I'm like, what the heck is that? And
Yeah,
I kept going.
so they're basically doing the same thing that I am doing. They're just not
Okay,
showing it the same way. So
okay,
I plugged in -3. They're just saying we plugged in -4. And then they said, okay, the answer was 42, so that gives us a positive. And what they're doing is they're plugging in not into the factored form, they're plugging it into this whole thing with a quadratic, which I think is harder to plug it in, because then you need to do quite a bit of math.
okay.
So, and so they're doing the same thing. They're still plugging in numbers, but they're plugging it into the multiplied out version, while I'm doing it in the factored version, which is less math to do. It's a lot easier to plug it in. And then all you have to do is, there's fewer mistakes to be made because you're just looking at the signs and multiplying and dividing.
Right.
I I don't know where I picked up this trick, because honestly, I've never seen it. We've used multiple textbooks and I've never seen them do this trick that I do, and I don't know where I came up with it. I don't know
Hmm.
if it's something that I just figured out on my own or I saw another teacher do it. I wish the books would teach it the way that I did, because I think it makes more sense than this whatever thing they're doing here.
Yeah, because it threw me off last night. I'm talking about I redid, let me see, one, like I got stuck on question 4. I redid it 1, 2, 3, 4, 5, 6 times, and I
Mhm.
missed each time, every single time.
It's so easy to make a sign error when you do it their way versus I think with my way it's easier to even double check yourself, because you can just look and say, oh, let me double check that this comes out negative.
Right,
And the trick, what a nice little trick to verify is that these shouldn't change, like they shouldn't be alternating. You're going to have a group and it will change sign at where the 0 is for that. So what I mean is for 4t minus 5, it's going to change sign to the left and the right of 5/4. So if you have the same sign on either side of that part, that tells you messed up. You can see that these are opposite signs. While the t plus 2, that 0 is at -2, so that's where that one changes. And so you can also kind of double check that you did your math by just making sure it changes sign across that line where it's supposed to.